In this video, we're going to discuss the arithmetic series, that is also known as the sum of the arithmetic sequence. Let's have the formula that is used to this topic. We have f sub n equals n over 2 times 2a sub 1 plus quantity n minus 1 multiplied by d. So let's identify each part. S sub n is the sum of the terms in arithmetic sequence, where n is the number of terms, a sub 1 is the first term, and d is the common difference. So let's use this formula in answering our problems. So this one, find the S sub 10 or the sum of the 10 terms of 6, 3, 0, negative 3, and so on. So this is our formula. So the given, let's identify. The A sub 1 or the first term is 6. The common difference is negative 3. So how is it obtained? By subtracting the second term to the first term, we have 3 minus 6, that is negative 3. 0 minus 3, that is negative 3. Okay, so the number of terms, or n, is equal to 10. And we have this unknown, S sub 10, or the sum of the 10 terms. So let's substitute the values. We have S sub 10 equals n is equal to 10. That's why we have 10 over 2 times 2 multiplied by the first term, which is 6, plus quantity 10, that is the number of terms, 10 minus 1, multiplied by negative 3, which is our common difference. Then let's simplify. So we have 10 over 2 becomes 5. 2 times 6 becomes 12. And 10 minus 1 becomes 9. Then simplify it more. We have 9 times negative 3 becomes negative 27. Then we have negative 27 plus 12, that is equal to negative 15. Then multiply it to our 5. So outside our parentheses. So the sum is negative 75. So that is the answer to the problem. Next is this. An arithmetic sequence has its first 5 terms, or first term that is equal to 5, with a common difference, which is negative 7. Find the sum of the 12 terms. Again, an arithmetic sequence has its first term that is equal to 5 with common difference that is equal to negative 7. Find the sum of the 12 terms of the sequence. So we have this formula again. So for our given, we have first term that is equal to 5. Then our common difference is negative 7. That is also given. Then n is equal to 12 because the 12 terms, or the sum of the 12 terms, that is we are going to find. Then S sub 12 is unknown. So we have, by substitution, we have 12 minus 2, or 12 over 2, that is n over 2. So the value of n is 12. Then we have 2 times 5. So a sub 1, or the first term, is 5. Plus quantity, the number of terms, minus 1, or 12 minus 1, multiplied by the common difference, which is 7, or negative 7. Then simplify. 12 over 2 becomes 6. Then 2 times 5 becomes 10. 12 minus 1 becomes 11. Then multiply it to negative 7. Then multiply it. 11 times negative 7, that is negative 77. Plus 10, that is negative 67. Then multiply it to 6. The sum of the 12 terms is equal to negative 402. Let's try this example. Find the first term, last term, and the sum of the finite arithmetic series that is represented by the sigma notation, or the sum of 3x plus 4 as x goes from 2 to 16. So how are we going to solve this problem? So let's have our solution. This is our formula to be used. Then let's identify the first term, or the a sub 1. A sub 1 is equal to, so the formula given here, 3x plus 4, and the value of x starts from 2. So we have 2 for the first term. So 3 times 2 is 6, and 6 plus 4, that is 10. So the first term of this sigma notation is 10. Then let's identify the second term. So why do we need to do that? Because of the common difference. Okay? So for the second term, the next value of x is 3. That's why we have 3 times 3 plus 4. Then 3 times 3 is 9 plus 4. So the second term is 13. So for the common difference, let's subtract a sub 2 minus a sub 1. That is 13 minus 10, and the common difference is 3. Then, for the number of terms, we're going to subtract the upper limit to lower limit, then add 1. So what is our upper limit? Our upper limit is 16, and the lower limit is 2. So we have 16 minus 2 plus 1. So that is the formula in getting the number of terms in our sigma notation. Again, upper limit minus lower limit plus 1. Then, the number of terms is, so we have 14 plus 1, that is 15. So n is equal to 15. Then, let's substitute. We're going to find the value of s sub 15, or the sum of the 15 terms of the arithmetic sequence. Then n over 2, that is 15 over 2, because n is equal to 15. Then 2 times 10, 10 is the first term, so we have 10 plus quantity 15 minus 1. So 15 is the number of terms. Then multiplied by 3, which is the common difference. Then simplify. We have, so let's stay 15 over 2. Then 2 times 10 is 20. 15 minus 1 is 14. Then let's simplify 14 times 3. We have 42. Then 42 plus 20, that is 62. Then we can cancel this. So they're both divisible by 2, or we can divide 62 by 2. So 62 becomes 31. So we have 15 times 31, and the sum of the 15 terms is 465.